Hello, good evening, everyone. In last session, we discussed about the 7 segment display. Okay, let me open the. Wait, I need to check what we did in the last session. PA6. Okay, this was the code, right? And PA6. Yeah, it's PA5. So let's open PA6. Yeah, so we did 7 segment display, but using IC 4511. BCD to 7 segment display in the last session. That means we tried to reduce the number of pins used for 7 segment display. Whenever we use 7 segment display, that time we need 7 pins to connect with any controller. So here we used IC 4511, which is basically called BCD to 7 segment display. So we converted the 4 pins logic to 7 pins using this IC. This was the last code which we had. So now let's start the new topic. I guess we haven't started the button interfacing or sensor interfacing in this Arduino controller. And this we did in AVR. So let's start with the next topic, which is your sensor interfacing. Sometimes, guys, it may happen that I'm if I forgot and start repeating the topics, please remind me that we have already completed this topic because I have a lot of batches and sometimes I may mix up the things. So yeah, now next topic is sensor interfacing, or we can also call it button interfacing. Button interfacing. So if you remember, we did the same interface in AVR controller as well, where we connected one button, considering that this is sensor, and one LED, which can be any other load as well, like motor, valve, or pump. So suppose if we are going to interface the sensor and we want to do a kind of automation here, which means if the button or the sensor is on, the lights or the load must be on, and when the button or the sensor is off, the light must be off, or any other load must be off. That's what we have to do using sensor interfacing. And as we did in the AVR controller, that whenever we consider button, that means we are using that in place of sensors. But this is digital sensor. So currently we are only talking about the sensors which give us the logic either 0 or 1. So let's start with the simulation. Always remember we have to start with the circuit only. And once the circuit is done, then we have to start writing the program. So let's pick Arduino Uno controller and one button. And one LED animated. Now let's drop Uno here, and then let's drop a button, and then let's drop the LED. So as we know, whenever we write the code for Arduino Uno, that time we have to program the pins, not the whole port. That means if I am connecting the LED with pin number 13, I can connect this button with pin number 12 as well. So let's connect it to 12 only. And then I'm going to connect this button with power, as this button is going to give the logic to your controller board. That means in this case, the Arduino board is going to receive the logics from button, and the pin number 12, which we connected with this button, is going to work as input. So if button is giving any logics to controller, that means the direction of current is inward to controller, as well as the button must have power to give any logic. If the button does not has power on the other terminal, obviously it cannot give any logic. It cannot give any logic like 1, or it cannot give any logic like 1, right? So we have to connect the other terminal of button with power and another terminal with the controller's pin. So here we have one button connected with pin number 12 and the LED with pin number 13. Now let's start writing the code for the same. So firstly, we have to define LED, which we are saying that int LED equals to 13, and then int B equals to B. I am considering a variable for button which is connected with 12. Now int BS equals to 0. So here I am defining one more variable as BS called button state. So if we try to understand using these two lines, which we understood till now, that LED is connected with pin number 13 and B is connected with pin number 12. So no, this was not the meaning of this line. What I told you, that LED is a variable which is connected, which is initializing with 13 and has the data type integer. And then if we talk about B is called button here. So B is a variable which has integer data type, and we are initializing this variable with initial value 12. In the same way, BS is also a variable which we defining as integer and initializing its value with 0. Now let's write the pin mode for the same. So pin mode LED comma output. So we are going to use this pin number 13 as output, and pin mode B comma input. We are going to use B as input pin, and BS is actually not any pin. We just took one variable BS to read the state of the button. So whenever button is on, that means we have the logic 1, and whenever the button is off, that means we have the logic 0. So we are going to store the data 1 or 0 which we received from variable button or pin button B, which is 12th pin, and that data, that logic, we are going to store in the variable BS. Now, whenever we come to loop to start writing the code for different conditions, firstly we have to read the state of the button, the value of the button, which means the first command always must be digital read, where R is capital, rest all small without any space. Digital read, and what exactly we have to read here? B. B mean pin number 12. B mean button. And once we read the data in digital form from variable B, let's store this in a variable called BS. So we are writing BS equals to digital read B. So now we have to put the conditions like we did in AVR as well, that if BS equals to 1, that means if you turn on the button, the state of button is 1, and then we have to turn on the LED. And another condition might be possible, that if we turn off the button, that means the state of the button is 0. So let's write how. If BS equals to 1, digital write LED comma high, and then else if. So now we are putting another condition, BS equals to 0, which means LED low. So digital write LED comma low. So the coding is almost done. Let's save this code with another name. The last name which we used was PA6 program Arduino 6. So now let's write it PS7, and also let's start compiling it. So meanwhile it is compiling the code, let's store the design in the same folder, which is batch 10 PM 21st June, in the folder of designs, and with the same name I'm doing it PA7. I do save the code and design with the same name so that in future we can identify both of them easily. So let's save it. Let's double click and then browse. So if the code is compiled, yeah, it's compiling actually. Meanwhile, let's close all other programs and come back to your Proteus. Now let's try to find out the code in the same folder PA7, and here we have the hex file. So let's run the program, and I'm going to turn on the button. So if I tap on the button, I can see the LED is on. But Even when the button is off, the LED is not off. Even when the button is off, the LED is not off. Let's check the code. Do we have any errors here? We said if button state equals to 1, turn on the LED, and if button state equals to 0, turn off the LED. So there is no problem in the code. Everything is fine. When button is on, the LED is on. When button is off, the LED is off. So the code is correct. We can also write the code in this way. Else, which is understood, if the button is not on, we have to run this case, and or the compiler has to run this case. That means if button is not on, obviously it's off, because we do not have any other condition except on and off. We have only two logics in binary, which is 1 and 0. So the code is same whether we write if bs equals to 0 or if we do not write this. Both are the same things. But still the LED is not on. So if you remember, we faced the same issue during the programming of AVR microcontroller. What we did that time, we connected one register which is called pull down register concept. Because if we do not connect the register and ground here, this pin number 12 is never getting the ground, because there is no logic like blue here. So red indicates logic 1, blue indicates logic 0, and gray indicates logic null. So we can see there is no logic here. It's null, which means the second condition is not satisfying here. So if I connect the ground directly, then whenever we turn on the button, this logic which is traveling through this button to pin number 12 is not going to receive the logic 1, because if we connect the ground here, the logic 1 will reach directly to ground, because current always choose the shortest path to travel. That is why we are connecting one register and then a ground here. Now if I play, no need to change anything in the code as it's already correct. If the button is on, LED is on. If the button is off, the LED is off, because now we have the logic 0 here. So once we receive the logic 0 at pin number 12, it's going to verify the second case, which means the LED must be off. That is it for the code. If you have any questions, doubts, you can ask. Questions are most welcome. Okay, no answer mean no doubts. Let's skip and go to the next topic. So now, not topic exactly, we are not going to change the topic for now. Still we are into the process of sensor interfacing, but it was only one sensor. Now I'm trying to include more sensors. So let's pick another LED and connecting it with pin number 12, connecting the same with ground. And now let's connect one more button. So I'm going to connect one more button here. So let's pick button and this I am connecting with pin number 7, and this I am connecting with pin number 6. Oh, sorry, we need to connect the button. So now as we have two buttons, so we need two different registers for this. So let's pick one more register and connect it to another pin. So this I'm connecting with pin number 6, and this I'm connecting with pin number 7, and then let's make it ground. Fine, and let's make it power. So buttons, both buttons, one terminal has the power and another terminal is another terminals are connected with pin number 7 and 6 respectively, and in parallel they have two different registers of 10 kilo ohm R1 and R2. Now let's go to the code. So let me copy the whole code and paste it to the new file. This time we have two LEDs, so let's define two different variables for LEDs, LED1 and LED2. LED1 initializing with 13, LED2 initializing with 12. And then we have two buttons. Button 1 is connected with 7. So let's initialize this variable with 7 and int B2 equals to 6. Then we need to take two different variables to read the state of two buttons. So B1S is the state for B1 and B2S is the state for B2. Now in pin mode, we have LED1 comma output and B1 comma input. Let's write more pin mode LED2 comma output and pin mode B1 comma input. Now let's come into the loop. The first task should be to read the value of first button. So B1S equals to digital read B1. And just after this line, let's read the another button, which is B2S equals to digital read B2. So we have two buttons, B1 and B2, and then two different variables, B1S and B2S, to read the states of both B1, B2 respectively. Now let's compare. If the first button is on, we have to keep the first LED on and the second one as off. So digital write LED2 comma low. And then if we're writing, if B2S equals to 1, then digital write LED1 comma low and 2 comma high this time. So we have mapped both the buttons with two different LEDs, LED2 comma high. Now if we include more cases, like if both the buttons are on, we have to turn on both the LEDs. And if both the buttons are off, we have to turn off both the LEDs. So how we can do that? Firstly, we have to write a condition. If suppose we have first LED on with button 1 and second LED on with button 2, then that is enough. The code which we just wrote is enough. But now let's suppose if we have one other different condition, which is what? If button 1 is on, LED1 is on, button 2 is off, LED2 is, button 1 is on, LED1 is on, button 2 is on, LED2 is on. And if both the buttons are on, both LEDs must be off. And if both buttons are off, then also both LEDs must be off. So in both the cases, when both are on, when both are off, we have to keep the LEDs off. That means we can simply write one more case as else digital write LED1 comma high, low, and digital write LED1 comma low. In both the cases, when none of the button is on, we are keeping both the LEDs as low. So let's save. We'll try to get something new in this code definitely. PA8. And let's save this as well. PA8. And now let's compile the code. Let's go to Proteus, double click. As the address of the code is changed, the directory is changed, the name is changed. So let's try to find out the hex file for another one, which is PA8, program Arduino 8. Code is still compiling. That is why we are not able to see the hex file here. Now it is available. That means the code is completely compiled. Now, if I turn on the first button, the first LED is on, the second button, the second is on. If both the buttons are on, still only one LED is on. Even though we wrote the code for two different conditions in else loop. If first button is on, turn on first LED. If second button is on, turn on second LED. But if both are on or off, we have to keep both the LEDs off. So the case which we can see here for now, both the buttons are on, but still both LEDs are not off. And why it is happening? Let's try to understand this thing now. So actually, when we turning on any button, so let's suppose the code is compiling and compiler is running all the conditions one by one. First, starting from this condition, if button 1 is on, turn on the first LED. As we have to keep both the buttons on, but yes, we can do that one by one only. This is not possible to keep both the buttons on at the same time. Even though if we are working on the hardware, we have two different fingers to turn on both the buttons together. But as we are human being, and if we try to do, somehow we or our fingers may get appropriate difference turning on both the buttons together. That means although we are trying to keep both buttons on together, but somehow it will take 10 milliseconds or 1 milliseconds gap between both the fingers. So what exactly happening here? If we turning on the first button, it's satisfying the first condition. And even if we press the second button, still it is stuck in the first condition. And why so? Because first condition is still satisfied. Your compiler run another condition when the first condition is not true. If the first condition is true, why it will go to check any other condition? So currently what's happening here? If condition 1 is true, it's not going to check another condition. So we have to make this condition false to run the else loop. As we are saying, if both the buttons are on, which means, as we are saying, if both the buttons are on, which means we have to put something here to false this condition. And how we can do that? We can write b2s equals to 0. So this was the new thing which we are doing in this code. And at this time, we are saying b1s equals to 0. So here, b2s is off and b1s is on. And here, b2s is on and b1s is off. So we have mapped both the condition. This condition will work when only one button is on, which is first button. This condition will also work when only one button is on, which is second button in this case. And this condition will work for all the rest cases. And what are all those rest cases? Both buttons are on and both buttons are off. So let's now try to compile. Let's go to this, browse, and okay, the same file. Okay. Let's run this. First on, first on, second on, second on. When both are on, both are off. When both are off, both LEDs are also off. So now each and every condition is working perfectly. Now let's add one condition. Suppose if we need, when both buttons are on, both LEDs must be on. So let's write one other condition here before this else if both are on, which means B1S equals to 1 and B2S equals to 1. And this time we have to keep both the LEDs off. So which means LED 1 comma low and digital right LED 2 comma low as well. No. We have to keep both the LEDs high at this time when both buttons are on. So let's make it high. And also let's make it high. So now we have four different conditions. We are mapping first LED with first button, second LED with second button, both LEDs with both button, and both LEDs off when both are off. So here, else loop will work perfectly. And if even you want to write the condition, you can add if here. So B1S equals to 0 and B2S equals to 0, then both LEDs are off. So we can do in this way as well. There is no problem. Let's export the code and check how is it working. Okay, now let's play. And first is on. So the first LED is on. second is on, so the second LED is on. And if both are on, both the LEDs are on. And if both are off, both the LEDs are off. Fine. So if you have any questions, you can ask me. Otherwise, we will try to interface these sensors or buttons with any other hardware output component.
No doubt, sir.
Okay, fine. Let's start the new design. So now we are going to make the keypad which we made in AVR controller. So first of all, we have to complete all the topics we did in AVR, and then we will start few new things as well. Also, can you please confirm me that have we completed the for loop in this?
Yes, sir.
Okay, good, fine. So let's start keypad interfacing. And we are not going to use any predefined keypad. We will make our own keypad with the help of buttons. So let's write 10 numbers 0 to 9, which means we need 10 different buttons. And to write the code or to print the data, we need one 7-segment display. So in total, we need 10 buttons, 7 segment, that means 17 pins. But it is not possible with Arduino Uno, because here in Arduino Uno, we have only 14 digital input output pins. So this wouldn't be possible to connect all 10 buttons and 7 segment. So we can use one IC to reduce the number of input pins for 7 segment. And we know very well about that IC. So firstly, let me pick 7 segment common cathode and the IC 4511. And then let's pick keypad buttons. And if we have button, obviously we need registers as well. So let's use registers as well. Now, firstly, I'll try to complete the connections for this IC. So I'm just connecting pin number 13th with A, pin number 12th with B, pin number 11th with C, and pin number 10th with D. Then let's connect 7-segment common cathode. This I told earlier as well, that we can use this IC 4511 with 7-segment common cathode only. We cannot use this IC with common anode because it converts the logic of 4 pin to 7 pin in terms of common cathode only, because common cathode need logic 1 to turn on the segment, and IC 4511 also converts into the logic 1 to turn on the segments. In case of common anode, we need logic 0 to turn on the 7-segment, and this ID does not provide logic 0 to turn on the segments. But yes, we have another solution for that as well. We can connect one NOT gate IC, or we can also use operational amplifier as NOT gate to just reverse the logic of IC 4511 in case of 7-segment common anode. Yeah, so we are done with this. Now we have to just connect the power. So let's connect the power with pin number LT and BI. LT is called lamp test, BI is called bit inverse. And let's now connect the ground to latch enable. Also, let's connect one more ground, or otherwise you can also connect this ground directly here. Now let's put 10 different buttons. So I'm going to select the button. We need 10 buttons. So let's drop them one by one. 3, 4, 5, 6, 7, 8, 9, and 10. Now let's connect them with all the. Sorry for the interruption. I don't know why my Wi-Fi reset every day at the same time. Okay, so let's continue. I was saying to connect all the buttons with the remaining pins of controller. So I'm starting with pin number 9, pin number 8, then pin number 7. Then let's connect another with pin number 6, and then 5. So almost we have connected 5 buttons now. Now only 5 are remaining. I try to connect the wires in very clear way, so that suppose in future if the code is not working after writing it, we can at least check the hardware where exactly we have the problem. If we overlap the wires, there is no problem. It does not get short, but uh, the problem is only one. If code works at first attempt, that's fine. But if it doesn't, we need to troubleshoot. And then troubleshooting is very difficult. And now if I connect the power with it, now the remaining part is to connect registers only. Now let's start connecting 10 different registers for all the buttons. So let's start with the first one. I am rotating these registers. 1, 2, 3, 4, 5. In few PCs, if you are facing the issue of duplicate part reference, that is because we connect when we drop the registers. In my case, it's showing all the numbers like R1, R2, R3. In some cases, it's not necessary that it will show you all the numbers. So because of that, what it puts on the screen, R question mark, R question mark, R question mark, which means there are lot of duplicates in your circuit. So that time we have to basically assign the names to those variables or those labels of your components. So for example, if it is R7, I want to change, I can double click and change it. Okay, for now I'm not going to change. Okay, it's creating problem connecting register R8. We will see it later. I'm leaving one button, this one, and let's connect it here. Let's connect this one to this. This now we have to connect. And then the last one, which to be connected with pin number 9. Let's drag this wire as it's overlapping. Fine, now we connected all only except this. Now let's connect this one as well. Okay, so another terminal of these register we have to connect with ground now. So let's short all of them together and then let's connect them with ground. Okay, done. Now let's create the code for this. File new, and as now we have total 4 variables for 7-segment displays with 4511. So let's write int b1 equals to, not b1. I'm writing the names as A, B, C, D. So A equals to 13, int B equals to 12, int C equals to 11, and int D equals to 10. Now let's write int B1 equals to 9, comma, B2 equals to 8, comma, B3 equals to 7, and terminate. Then int B4 equals to 6, B5 equals to 5, and B6 equals to 4, and terminate. Then int B7 equals to 3, B8 equals to 2, B9 equals to 1, and let's terminate. B10 equals to 0. Now let's define the variables for all BS1, comma, BS2, comma, BS3, comma, BS4, comma, BS5, and then int BS6, comma, BS7, comma, BS8, BS9, and BS10. If the class gets over automatically, you can complete this code by yourself, because we have done this in AVR as well. So it's very easy. Let's write now pin mode for all the pins. Pin A output, and now I'm copying this line, and let's paste it 3 more times, B, C, and D, and D. And now let's copy it again, paste it again, and I'm saying it input, and here we have buttons B1. Now let's copy and paste it for 10 times, and let's edit it. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now in loop, let's read. So digital read. First, we have to read first button and store the data to variable bs1 equals to digital read b1. Now let's copy this line and paste it. So now we have to change it to 2, 3, 4, 5, 6, 7, 8, 9, and 10. And also we need to change here as it's 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, and then 10. Now we have to compare it. So I'm starting with the first condition. If B is 1 equals to 1, which means we have to print 1.